Hello students, in today's class we will continue the chapter work, energy and power. So in today's class we will derive the expression for kinetic energy, that is K. So for this let us consider a body of mass m. Here A is the body of mass m which is at rest. Let it is subjected to a constant force, that is capital F. This force produces acceleration, so it moves to the distance s with the final velocity v. So next is, you are all familiar with this equation of motion, that is v square is equal to u square plus 2as. Let us consider this as equation 1. So as I said, this body of mass m is at rest, so we'll consider this as initial velocity to be 0, that is u is equal to 0. What happened to the equation 1? V square is equal to 0 plus 2as, or we can write it as v square is equal to 2as, and we'll take v square and 2a this side, that is s is equal to v square by 2a. We'll consider this as equation 2. Next, the work done by force is given by W is equal to F dot S. In the previous class, we have defined the work done. So, Fs cos theta. So, what will be the theta? As F and S are acts in the same direction, so theta will be 0. So cos theta is 1. What happens? W is equal to Fs. So what is F? According to the Newton's second law, F is equal to ma. So ma, yes. So W is equal to, what happened to the equation? W is equal to ma. What is S from the equation 2? That is v square by 2a. So from equation 2, we can write S as v square by 2a. So F is ma. So what happened to the equation? Totally W is equal to ma v square by 2a. So next is AA, will cancel it out. What left? W is equal to half 1 by 2 m v square. So we'll consider this as equation 3. So half m v square is the kinetic energy equation. So K is equal to W and K is equal to half m v square. So we'll consider this as equation 4. So equation 4 gives the expression for kinetic energy. So next we will understand the work energy theorem. So what is the statement of this work energy theorem? It states that the work done by a force acting on a body is equal to change in the kinetic energy of the body. So let us write it in the equation form. So W is equal to half m v square minus half m u square, which is the change in the kinetic energy, and W is the work done by a force acting on a body. So W is equal to half m v square minus half m u square, or we can write it as kf minus ki, where ki is the initial kinetic energy of the body and kf is the final kinetic energy of the body, and where W is the work done on the body by a force acting. So let's study the proof of the work energy theorem in case of rectilinear motion under a constant acceleration. So let us consider a body of mass m moving with an initial velocity u along a straight line, because it's a rectilinear motion, along a straight line under constant acceleration. So let v be the final velocity of the body, and S is the distance travelled by the body, and F is the force applied on the body in the direction of motion. So you are familiar again with the equation of motion, that is v square minus u square is equal to 2as. Let us consider this as equation 1. This is the equation of motion, that is v square minus u square, which is equal to 2as, where v is the final velocity, u is the initial velocity, and a is the acceleration, and s is the distance travelled by the body. Now multiplying both sides of this equation 1 by m by 2. So what happens? We'll take it as half m v square minus half m u square, which is equal to 2 get cancels. What we can write it as m a s. So we'll write as it is the half m v square minus half m u square. Next what we'll do is ma is nothing but f according to the Newton's second law, f dot s. So f dot s, we'll write it as w in the next equation, and half m v square is the final kinetic energy and half m u square is the initial kinetic energy of the body. So kf, that is the final kinetic energy, and minus ki is the initial kinetic energy of the body, which is equal to w, that is f dot s, that is work done by a force acting on a body. So let us consider this as equation 2. So this equation follows that the change in the kinetic energy. So here is the change in the kinetic energy of the body is equal to the work done on the body by the force. So this work energy theorem is a very important theorem as per your examination is concerned. Write down the statement, the equation of the statement, and then do the proof of this theorem.